So the good news is we just have this last very tiny bit of content to go over. It's like one slide. So I pulled out a little bit of comparison between the male and female reproductive systems that I want to highlight for you after we go through that, just as a review, because I think it makes it kind of easier to remember some of the things. So it's nothing that you haven't seen before. It's just I pulled out different figures from your slides to do a kind of side by side. But we'll probably finish up early today. Next time on Wednesday, what we'll do is we'll review for this exam 4 that's coming up, as well as talk about the final. Like last semester, we have a cumulative final, half the length of a normal exam, but we do want to make sure that we're prepared for all the topics we've covered this spring. So we'll touch base, remind you about a couple of those. And your reminder that you can do one retake of your choice if you so choose right after the final. So we can touch back on any of that content if you want. Okay. So our last little piece, we had left off with this figure and we were talking about hormonal changes during pregnancy. So we've seen how our hormones vary during a normal menstrual cycle. So we've seen that estrogen spikes twice, basically, once in the follicular phase as we have those follicles growing, then decreases a bit at the end of the follicular phase when we see a spike coming from the hypothalamus and anterior pituitary with our LH and FSH, and then a second spike of estrogen in the luteal phase, which is also when we see a spike in progesterone. And compared to pregnancy, you can see that those two hormones are doing something different. They're basically both ramping up throughout the whole course of a pregnancy until right before birth. Okay. So the way that we're making that happen is through this hormone HCG, human chorionic gonadotropin. Okay. So what happens when fertilization occurs and we have implantation of a successful pregnancy, that embryo starts to grow. We're growing this whole new organ as well in the uterus called the placenta. It's essentially is giving the growing embryo and then the fetus blood, helping with gas exchange, all that good stuff. It is also secreting hormones, including this one, this HCG. Okay. So what that HCG does is it sustains our corpus luteum. Okay. So that's our ruptured follicle in the ovary. It's turned into a gland. So we know that usually during the luteal phase, it's largest around day 10 of that luteal phase and then starts to regress and get kind of reabsorbed. And we don't want that to happen in the case of a successful pregnancy. We want it to stick around because in the early months, that corpus luteum is going to keep producing estrogens and progesterone. And as you can see, we want those estrogens and progesterone going up for the first 2 months, and then they're going to keep going up and up and up. Okay. So HCG from the placenta is what makes sure that that doesn't kind of get resorbed into the ovary and it sticks around and continues producing these hormones. Okay. So this is one of the things that they're looking for in a pregnancy test is this hormone that's being secreted because this is not something that you're normally secreting in like day-to-day life. Okay. So for the first 2 months, that corpus luteum, that gland is sticking around and secreting these hormones, giving us a fair amount. Sustained by this HCG. But after that, we want to keep making estrogens and progesterone, but in greater quantity. So we're going to use this bigger structure, the placenta, to take over. So the placenta is then going to take over the progesterone and estrogen production both until right before birth here. So I want us to, well, yeah, we'll notice that in a second. Okay. So one of the things that progesterone is doing here is it's inhibiting future LH surges by inhibiting our GnRH coming from the hypothalamus and the LH and FSH that we usually see spiking right before ovulation. So the fact that it's going up is particularly helpful for making sure that you don't accidentally like ovulate another oocyte like 2 or 3 months into your pregnancy and then end up with kind of a mess. So that's helpful that that's increasing throughout pregnancy. We might also want to notice that both progesterone and estrogen are dropping really precipitously right here at the moment of birth. They're actually, especially progesterone, dropping like right sort of when labor starts. And to think about that, we want to remember what we did go over last time. All right. Estrogen's job, one of its jobs, is to be growing how our uterus is able to contract and growing how responsive it is to signals for contraction. Signal partially comes from oxytocin during birth, right? So that's increasing over the course of pregnancy. And you can see how much higher it is than progesterone, especially in the later months, right? So sometimes, often, usually, people are going to experience some like false labor pains, some like contractions that are starting before the actual moment of birth. We think probably this has to do partially with this high amount of estrogen and this kind of divide between estrogen and progesterone. So progesterone is supposed to be suppressing that contractile activity of our now very strong uterus, but we can see that that progesterone drops off just about, but right before the estrogen does, right? So it's going to stop suppressing that contractile activity at birth. So the now very strong uterus from the growth enhanced by estrogen is going to be contracting. And the trigger for that contraction is largely from oxytocin, which is a posterior pituitary hormone. They're like essentially, they think sensors for the fetus kind of like pressing down in the uterus that help influence the release of oxytocin from the pituitary. So that's what happens at birth here. Okay. So we got this figure, and we want to make sure that we can tell when we're looking at these hormones, are we looking at a normal menstrual period? Are we looking at a 28-day cycle, or are we looking at the course of a pregnancy? We want to make sure that we can tell all our graphs apart in this unit. Okay. So onto that comparison that I think can make studying a little easier as we're putting together these two different systems. So we have a lot of parallels and a lot of things are the same. Of course, what's going to be really important for telling the two apart is the differences. So we want to make sure that we've got a sense of our kind of compare contrast between the male and female reproductive systems. So one of the ones that we did kind of explicitly when we were talking about sex differentiation is just how we form them, right? So we know that we start out with this indeterminate state in embryonic life where we've got our Wolffian and Müllerian ducts around a primitive gonad that isn't an ovary or a testis yet. Okay? So if we're going down our male reproductive tract route, we're going to see that Wolffian duct develop. And if we go down our female reproductive tract route, we see that parallel structure, the Müllerian duct develop. All right. So for our male reproductive tract, we need a signal for that to happen. So we need an SRY gene on the Y chromosome. SRY gene codes for TDF. TDF is what tells us to produce testes, which are our gonads in the male reproductive system. And then the testes produce their own hormones, including testosterone, whose main job in this context is to tell that Wolffian duct to keep growing, and MIH, whose job is to inhibit that Müllerian duct. For a female reproductive tract, this is what's going to happen automatically if we get no signal. So in that case, we've got this kind of developmental trajectory just baked in. Without a signal, we're going to turn our gonad into an ovary. We're going to see the Müllerian duct continue to grow, and the Wolffian duct will just degenerate down. So that's one thing we can compare. Is how do we get these two tracts? Where do each of the pieces come from? Another thing we might want to compare are the different cells that produce hormones, right? Because we're tracking like testosterone in males, we're tracking estrogen, progesterone eventually in females, okay? So we have some cells that kind of parallel each other here. One thing we want to be aware of, right, is our testosterone in the males is coming from these Leydig cells, kind of outside our seminiferous tubules. And then in the walls of our seminiferous tubules, we have these Sertoli cells that guide the development of sperm. Okay? So those Sertoli cells, we can kind of think of as having a female equivalent when we look at our growing follicles. So if you wanted to draw a parallel here, you notice these granulosa cells all surrounding our oocyte. Okay. So our Sertoli cells are a target of hormones. So they're a target of testosterone from the Leydig cells and FSH, our follicle stimulating hormone. And they produce this hormone inhibin that does a negative feedback loop on these anterior pituitary hormones. In the female reproductive tract, if we're looking at those granulosa cells that are the equivalent, just like the Sertoli cells, they're a target. So they have receptors that are receiving signals from estrogen and FSH, right? So both of these are getting that follicle stimulating hormone. We're just swapping out the female hormone for the male hormone. And they also produce inhibin, just like the Sertoli cells do. But an added little piece, they're going to produce estrogen eventually as well. Okay. All right. So we have flow charts in your book too that roughly parallel each other. So you can pull out some of that information for a comparison as well. So in this case, we are looking at spermatogenesis and oogenesis and follicular development. This is our kind of earlier stage in our early to mid follicular phase is what I think I pulled out here. But we can see that when we're looking at this development stuff, we've got the same hormone from the hypothalamus. That's our initial stimulus. So that's that GnRH. We've got the same hormones coming from the anterior pituitary. So FSH and LH are things you see in both of these. Well, we've got a little bit of different stuff going down as we look at the cells in the gonads themselves. So we just mentioned the Sertoli cells and the granulosa cells being kind of equivalent. You can see them both producing inhibin, creating negative feedback loops on FSH specifically, right? So both the Sertoli cell and a granulosa cell are doing that, right? The Sertoli cells, we don't have to worry about more hormonal stuff. We're just thinking about spermatogenesis happening there. Our second type of cell was the Leydig cell, which we're making testosterone. In our female, we do have another type of cell that would also produce an androgen. It's not testosterone specifically, but another actually kind of male, quote unquote, hormone here, the theca cells, which are an outer layer kind of outside the granulosa cells when our follicles start to get larger. Those androgens get modified into estrogen in the granulosa cell, which is why we think of the granulosa cell as producing estrogen. I would consider the theca cell to be like a little additional detail there, but if we're drawing these parallels, it can be kind of helpful to notice that. Yeah. And we've got this negative feedback loop from estrogen onto our anterior pituitary and the hypothalamus in the early to mid follicular phase. We know its action kind of changes as we get to the point of ovulation. But in this early to mid follicular phase, we can see that negative feedback from estrogen, just like we can see negative feedback from testosterone on the male side here, right? So we can see that suppressing our anterior pituitary and hypothalamus as well. So we can see traces of this kind of parallel that exists from embryonic life into adult life, right? A little bit of tweaks here and there, but we've got a lot that's similar too. Yeah. So the final thing, I think it's particularly helpful to notice similarities and differences between our spermatogenesis versus our oogenesis. Noticing the similarities is particularly going to help us remember the names of these structures, right? We can see that we have spermatogonia and oogonia. We have primary and secondary spermatocytes. Then we have primary and secondary oocytes. And eventually we end up with spermatozoa and an ovum. Those aren't parallel sounding terms, but we get pretty far with these matching terms. Okay? And we've got a little bit of parallel in what's happening as well from a perspective of what phase of meiosis is happening. But we want to make sure that we know that the timing with respect to someone's lifespan is super different here. Okay? So when we're looking at spermatogonia versus oogonia, right, those are both our diploid cells. Those are both the ones that could undergo mitosis and make exact duplicates of themselves, right? In the spermatogenesis diagram and in spermatogenesis in general, we have a spermatogonium that's sticking around here at this outer side of our Sertoli cells, right, this basal compartment, and continues to just make exact duplicates so that we can continue to make sperm throughout the lifespan once we hit puberty. Right? In the female, when we're looking at those oogonia, we're making extra copies only during fetal life, right? So this is all happening in a female fetus. It's going to be born with the maximum total number of primary oocytes that are ever going to exist in her lifespan, right? So those oogonia present only in the female fetus, because when we go to our primary oocytes, right, these are also being produced in fetal life, and they even start meiosis 1 in fetal life, right? So in the male, those primary spermatocytes, pretty simple, adult life, just undergoing meiosis 1. In the female, primary oocytes are complicated because we make them only in the fetus, start meiosis 1 in the fetus, but are then stuck in this meiotic arrest until right before ovulation. So like basically right as you're ovulating, we finish up meiosis 1 and get our secondary oocyte. Okay. So looking at those secondary oocytes versus our secondary spermatocytes, right? Secondary spermatocytes, just doing their usual thing, right? So primary spermatocytes did meiosis 1, secondary do meiosis 2 in an adult human. When we're looking at our primary oocytes, they were in meiotic rest. We only made secondary oocytes just after ovulation or just at ovulation, right? And then those secondary oocytes are only going to finish up meiosis 2 and create our ovum at fertilization. So this happens when they encounter a sperm and it like actually pierces into that kind of casing around our oocyte. That's our trigger to finally finish our meiosis process here. We didn't mention when we were looking at these figures before, but it's kind of obvious looking at it now, so I'll just point it out in case we're curious. We can also see in the comparison here, right, that one spermatogonium is going to give us 4 spermatozoa. But if we were to trace one oogonium, we notice that down at the bottom, we actually only end up with 1 ovum. So since I didn't have us go through all the details of exactly how meiosis works in each of these systems, this is a kind of finer point. But just so you know, the reason this is happening is we're basically not splitting like the cytoplasm evenly in half as we go through these phases of meiosis. You can see we're basically giving everything to this one oocyte and eventually this ovum, keeping it large. So even though we're technically splitting stuff up, the other cells just turn into these polar bodies, we call them. So they're not their own like eggs that can be fertilized. They're just kind of there, kind of degenerating there. Okay. So hopefully that helps. If it not doesn't, ignore it. But I think seeing that parallel can make it a little bit less to study if you can kind of highlight what's the same between each. Okay. So that is what I have for us today, in case unless anybody else has stuff that they want to go through. No, I get to be done. Okay. So Wednesday we'll have a study day. I'll bring some activities and stuff that we can do for this unit, as well as pull together some reminders regarding our final, make sure we're all solid on what's going into the grade book, when, how to kind of predict our grades and that.